In this video, I'll be documenting my answering of several practice questions on exponential and logarithmic functions. Well, basically finding their derivatives. So before we do that though, as you can see, I've already started 1 and 2. I think we have like 28 questions, but we're definitely not answering everything. So yeah. So where do I start? Okay. Exponential function looks like this. So f of x is equal to a raised to x. And for a natural exponential function, f of x is equal to e raised to x, such that e has a specific value of 2.71828. So this is, I believe, is Euler's number. And as you can see here, this is a. That's basically the base in a logarithmic function, as you can see here. So log x base a is the base. If you look here, this is how I memorize how you convert from logarithms to exponential form, and vice versa. So it's gonna be log ab equal to c. So abc, that's easy to assimilate, and the base is going to be the base as the exponent is c. So you can say that the exponential function here, so that's going to be equal to a raised to x. It's not from a different universe compared to saying that f of x is equal to log x base a. So yes, there's a policy that a is greater than 0 and it's not equal to 1. For the natural logarithmic function, f of x is equal to log x base e, and this is also equal to ln x. So this I'll have to remember. I don't, this is kind of new to me. Everything else isn't. Okay, so let's go to the derivatives of exponential functions. Let me just verify if I'm recording. Okay. So the derivative of a raised to x is equal to a raised to x ln a. Okay. And yeah, general policy is a is greater than 0 and it's not equal to 1. That's standard. So let's say that we're looking for a raised to u. It's not different from this. Although there will be a time when you'll need to also multiply this expression with du over dx. That is basically the derivative of your, I believe, your exponent, which is u. We'll see later. It's either that or, well, yeah, I believe it's just the exponent. Either that or a, the derivative of a. We'll see. For the next one here, so the derivative of e raised to x, I've mentioned this in the previous video. It's the same. It's just e raised to x anyways. And the derivative of e raised to u, well, it's the same concept, but you just multiply it with the derivative of your exponent, which is u. Okay? Well, I may not be able to explain the formulas in the most expected manner, but it has to be, I'll be demonstrating the formulas later when we start solving. Okay, so those are the derivatives of exponential functions. It's easy to memorize. Ideally memorized already. So, derivatives of logarithmic functions. We have the derivative of log x base a, that is equal to 1 over the x from here, you put it there, and then ln, and then the base, which is a. So, in another way, you can say that it's the derivative of log u base a is equal to 1 over u, the exponent. Oh, no, just the u. And times ln, and then a, the base, times the derivative of u. Okay? The next is the derivative of log absolute value of x base a. So it's essentially the same thing. It's still 1 over x ln a, the same as this. And it's the same thing for derivative of ln absolute value x. It's still going to be equal to 1 over x. So 1 over x is also basically the derivative of, well, the derivative of ln x is also 1 over x. Okay? And there will be a time when you'll have to multiply. So it's going to be 1 over u if we have ln u instead. I'm not saying that x and u are different in any way. But yeah, there's a reason why I highlighted these formulas as blue. These are yellow. I prefer that you would look at these formulas more. Because this is a very important part. Not being able to solve for du over dx and multiplying it with the main expression, it's going to be problematic. Especially when the computation is already kind of crazy already, if you know what I mean. Okay, let's have a debrief for numbers 1 and 2 since they've already been answered. So for number 1, the derivative, so y is equal to ln, and then we have in a parenthesis x squared minus 1. Let's we will always recognize this as u. At least that is my technique. So ln u, so the formula is this. That's what we use. And that's already been written. This one. So identify the u and identify the derivative of u, which is 2x. As easy as that. So just substitute the values. So 1 over u is x squared minus 1, and then times 2x. And if you simplify, well, just multiply, you get the answer already. Number 2. So how about the ln of cosine x? Same formula. Identify u, that is cosine x. How about the derivative of u? Or in other words, the derivative of cosine x. That is going to be sine x according to the list of derivatives of trigonometric functions. So again, wait. Just to give you a reference, this has been discussed in the previous video. So yeah, ideally memorize everything. You don't forgive in calculus. You memorize the formulas because they are necessary. Otherwise, there will be a time when you won't be able to solve a specific problem because you didn't know the formula. You don't want yourself to reach that point. So, yep. Anyways, so cosine, the derivative of it is negative sine x. So 1 over cosine x times negative sine x, that's going to be this. And according to the trig identities, sine x over cosine x is tan. But there's a minus sign, so you put a minus. That's it. That's the final answer. Okay, next, number 3. So as we go through the questions, it's going to get harder and harder. So hopefully our limit isn't too short. Okay, we're still using the formula. So d over dx ln u is equal to 1 over u times du over dx, such that the u is equal to 2x plus 1, and the derivative of u is 2. Okay, so far so good. 1 over 2x plus 1 times 2. 2 over 2x plus 1 is the final answer. Let me confirm if that's correct. Okay, so something's wrong. Let's undo. So apparently this is not that's not the only thing that we're gonna do. we have an exponent here. So I suppose we apply chain rule. 2 ln 2x plus 1 times derivative of 2x plus 1, I believe. And yeah, don't forget, this is where it gets messy, because aside from chain rule, you need to integrate this here. So it's gonna be 1 over 2x plus 1. Well, yeah, that's it. Okay, so let me just make this clear. So in this part, what we did was bring 2 here. And as a result, minus 1, that's going to be 1. That's why we don't see an exponent anymore, because it's already self-explanatory. And so this one is written here. So d over dx is that. Okay. So as a result, let's just simplify. So 2 is going to be 4 ln 2x plus 1 over 2x plus 1. I think this is good. Although according to the answer key, we could still rewrite this as, that's weird. Let me verify with another source, just to be sure. So how do we bring 4 in an exponential position? At this point, let's just take note of it. So coming from here, it went there. So that's it. This is the final answer. Okay, number 4. d over dx log, what are our formulas again? X base a is equal to 1 over x ln a. X is this, ln, and then a is 10. So, by the way, we're not permitted to use calculators in the test, so yeah, you'll have to find a way. By the way, this was exactly what I was talking about, because you still have to do this. Well, this formula didn't have anything, so this one is what you're supposed to follow. So we identified u as 2x squared. How about the derivative of it? That's going to be 4x. So 4x. So 2 over x ln 10. I think this is the answer already. Let's verify. All right. Okay. That's it. Let's move to number 5. What are we looking at? 1 over ln x. Where do we see this kind of like this? Perhaps we use quotient rule because it's a fraction. So d over dx, dy over dx is equal to, okay, chain rule times ln x raised to 4 plus 3x cubed times, okay, what is the derivative of ln x raised to 4? ln u, right? And then that's going to equal to 1 over u times du over dx. So our u is x raised to 4. Our derivative of u is going to be 4x cubed. So 1 over, we'll write that down already. 1 over x raised to 4 times 4x cubed. And then divide everything by g of x, that is, in other words, the denominator, and then raised to 2. Okay, simplify. Four over x, 12x raised to 2. I believe that's that. I hope this is the final answer already. Let's check. So 9x raised to 2 and x raised to 4 minus. This is supposed to be minus. Oh yeah, in quotient rule, always remember it's going to be a minus sign, not a plus sign. My bad. I always make that mistake. So try to avoid it. That's all I have to say. Okay, 9x squared ln x raised to 4 minus 12x raised to 2. This one can be written as ln 2x raised to 4. And this is the final answer. I'll need to highlight this to take note that is possible. That could actually be done. Okay. Okay. I smell. Wait, I haven't smelled anything yet. I was gonna say no, product rule. Y is equal to, okay, d over dx log, what's this? X a? No. I'm mixing it up. Ax is equal to 1 over a ln, x ln a. Is it like that? Uy, memorized. I think I memorized it already. That's good. All right, let's resume. So we know that. Why are we using x? Can we assume that x is u in the formula, so we don't get confused, because this one's also x. So yeah. 1 over, okay, wait, u is sine 2x. How about its derivative? By the way, I almost forgot. Du over dx. Whoopsies. Okay, sine 2x. The derivative of sine x is cosine x. Then we just copy the the u value, which is still 2x. Okay, so now we use this formula. So 1 over u is sine 2x, ln, and then a, what is our a? 2, this one. And then times du over dx, the derivative of u, which is this. So we just write it here, cos 2x. Okay, cos 2x over sine 2x ln 2. This is the final answer. Let's hope that it's correct. Number 6. Ooh, okay. We missed something. Bruh. Okay, so apparently I missed another du over dx. So when I thought I already solved everything, looking for the derivative of sine 2x. Wait, let me verify. Yep, I missed something. So derivative of sine x is equal to cosine x times du over dx. Sorry, cosine u is equal, sorry, derivative of sine u is equal to cosine u times du over dx. So in other words, looking for u prime, that's going to be equal to cosine 2x times the derivative of 2x. That's equal to cos 2x times 2. Hence we get 2x cosine 2 as our derivative of u. So we put that here. And yeah, that's it. Let's check again. I need to review this. Basic mistake. 2 cos 2x sine 2x ln 2. Correct. Okay, 7. Alright. D over dx ln u is equal to 1 over u times du over dx. So, what do we do? Okay, I sense a quotient rule under this process. So, yeah, wait, let's actually do it now. So, u is equal to x plus 1 over x minus 1. U prime is, well, you apply quotient rule. X plus 1's derivative is 1, and then just copy the denominator, minus, copy the numerator, times the derivative of the denominator, which is also 1. Sorry. And then divided by the denominator, which is x minus 1, with the squared. So this is going to be x minus 1 minus x minus 1. So essentially, you get negative 2. So this is the derivative of u. We'll bring this a little farther. Okay, so what do we do now? So d over dx ln is equal to 1 over, what is our u? X plus 1 over x minus 1 times d over dx, or in other words, this one, that's going to be negative 2 over x minus 1 raised to 2. 1 over 1. So this is going to be x minus 1 over x plus 1. Okay. Cancel, cancel. 2 over negative 2 over x plus 1 times x minus 1. Let's see if that is correct. Either way, we can also express our answer this way. So yeah, this is my answer initially, but if I had known, this could also be an answer. Okay. So that's for number 7. Number 8. I enjoyed number 7 actually. Okay, number 8. Let's write the formulas we'll need. So ln, its derivative, it's going to be 1 over u times du over dx. What else? Let's rewrite the expression. We don't want radical signs. They make it look impossible to solve. Well, not really impossible, but they look ugly. So convert them into exponential form. So I smell a product rule that we have to do. So yeah, let's write that down. So what's the derivative of this? That's gonna be 1 over 2x raised to negative 1/2 times, we'll just copy, plus, and then just copy, times the derivative of, well, this one. So this is where we use the formula. By the way, we haven't computed for the u and u prime yet. Let's compute for it now. So u is, don't forget the radical sign. This could also be expressed as this. And finding the derivative of it could also be written as, okay. So 1 over u is 4 minus x squared raised to 1/2 times d over dx. So that's 1 over 2 times 4 minus x raised to 2 raised to 1/2. Okay, so the family is complete. That's our entire expression for product rule. Let's try to simplify, or just at least merge them together. So if these two multiply, they could be liberated. What I mean by that is they could be written as this, I think. Yeah, looks okay. Looks correct. Ln 4 minus x squared raised to 1/2 divided by I think that's it, chat. Let's see. Wait, if we want uniformity, if everything is in radical form, then at this point I think it's just a matter of preference. I think the x under the radical sign would cancel. Let's see. Oh wait, I'm so sorry, there's supposed to be a plus sign here. Am I that careless? Okay, so far this part is okay. That's correct. The other side, not really. What's going on? I always keep getting this mistake. du over dx. Wait, so that's gonna be negative 2x. So when they cancel, u prime has to be x over, well, just that. Okay, let's check again. This is for number 8, right? X squared root of x over 4 minus 2x squared. Okay, this is correct. Nice one. This we didn't have to do anymore. Okay, that's number 8. Number 9. For a while. Give me a minute. Answers for inverse. Definitions of inverse. For a while. Pardon me. Derivatives of, where is that? Okay. Okay, number 9. ln u. Its derivative is equal to u minus. I'm dreaming. Okay, that is the formula. But we're gonna apply quotient rule. That's just the quotient rule is the bigger piece. This is just a piece of it, if you get what I mean. So dy over dx. Hang on. Okay. F of x is gonna be. Wait, we need to look for the derivative of that first. So u is equal to sine squared x. U prime is cosine squared x. Wait. I'm not falling for that trick again. So if you want to look for the derivative of u, that's going to be, I don't know, sine raised to 2x. That's going to be cosine raised to 2x times du over dx. D over dx, that's going to be what is it going to be? Well, just x, right? Let me confirm. Okay. There's one discovery that that's important to know. It's this. I have to start earning for those. Okay, so far that's what I found. Are we still recording? Okay, good. Okay, so we can use chain rule. Okay, so get this. It's very important to know that if you're gonna differentiate or basically find the derivative of something like this, so you bring down first the exponent. So 2 will be there. So that's gonna be 2 minus 1, that's 1, so no need to write. And then multiplied by the derivative of just this one. Don't write the exponent anymore. Just follow that rule. And the u, you're gonna find the derivative of it too. So what's gonna happen is, well, 2 sine x. Just to let you know, if ever the u was just sine x, we would easily know what the derivative is. But then the only difference is we have a raised to 2, so this is not right. Okay? Just to clarify that. So derivative of sine x, well, like I just said, it's cosine x. And then x squared derivative is going to be 2x. And then we have 4 sine x cosine x. Sorry, 4x. Can we rewrite this as 2x times 2? Okay. Wait, what? So we didn't have to do this. So from there, it's an identity. It's going to be sine 2x. This is our u prime. Just in that process, it's already becoming difficult. I'll need to freshen up on this. Okay, 1 over u. U is sine raised to 2x. Yeah, it makes sense. Sorry. I'll go back here. Um, we don't have to find the derivative of x raised to 2. Because once, well, yeah, technically we still do. But if we're gonna look for that derivative, it's not going to look like this. It's gonna look like x. Because once we bring down 2, it's gonna be sine x raised to 1. And that's what we look for the derivative here. And the x here is gonna be the one that we're gonna find the derivative for. So yeah, okay, that's very important. Okay, next, times d over dx, that's the sine 2x, and then multiplied by the denominator minus, just copy the numerator, and then the derivative of the denominator is 2x simply. Divided by that one. Okay, so far we could rewrite this as I hope what I'm doing is right. Let's see. Number 9. Why does it look like this? This one's correct. You know, we can just rewrite this back as 2 sine x cosine x, so that these two can cancel. Okay, let's discard this. Cosine over sine, that's gonna be cotangent, right? Okay, there's something that's magical that's gonna happen again. So the 2 is missing, is gonna be 4 here. Okay, just observe what happened, because at this point, just make this a little longer. This is the final answer. Yeah. Hold on. Almost forgot about this one. But yeah, aside from that, we're good. Yeah, that's it. I'll need to screenshot this too. That's very important. I don't know. I think that happened twice already. So coming from the base, it went to the exponent position. Oh no, that's different. This one. So from coming from the base, it went to the exponent's position. Maybe there's a property behind that that hasn't been discussed yet. Oh well. The only common thing is that there's an ln before it. So maybe I guess that's the reason why you can do that. But yeah, okay. Number 10. I think we're gonna stop at number 10. I'll make a part 2 for the rest. This is a lot. Who knows? Maybe or maybe not. Let's confirm if my formula is correct. Okay. Oh wait, let's make it U. Ulna. How about ln? So let's find the ln of 4x minus 3 first. U is 4x minus 3. How about the u prime? Well, that's going to be 4. So this is going to be 1 over u times 4. 4 over 4x minus 3. Okay. I think we can start. Okay, so 1 over u. U is this one. And then times the base. And then du over dx, it's this one. Derivative of u, such that u is this. So 4 over 4x minus 3. Let me try the magic trick. Let's see if I get the answer this time. Huh. Okay, 4 is the numerator, that's correct. 4x minus 3 ln. Huh? Okay, let me guess this straight. This is getting really annoying. Because the answer key says it's 4 over 4x minus 3 ln 4x minus 3 ln 3. I'm not sure if that is the same thing as my answer, this one. Or maybe let's just not adopt the magic trick anymore, but just this. Let's say ln times 3. Maybe we could rewrite it this way, this entire thing. I'll ask this to my professor. Oh wait, it's not complete. But essentially, you get the idea, right? Because technically this is still multiplication, so I personally think this is the same as this. So yeah, just distributive property. Okay. Okay, I think I can still make I think I can still answer a few more questions. I have more time. Okay, number 11. Either that's gonna be just e raised to 4x again, or no, this is not. This don't look right. I think this is the answer already. Let's see. 11. Never mind. Yeah. The second option I wrote a while ago. Well, it used some elements from that logic. So note. So if you have something like this, so of course bring down to 4, and then times that. So that's it. A while ago, what I said was you're gonna put a -1. It didn't look right. Well, it's true, because that wasn't part of the correct solution, but somehow you brought the 4 down, and yeah, that was it. You just multiply it to whatever the given is. So this is the final answer. Sheesh. Yeah, we'll have to take note of that too. Y is equal to, okay, u is equal to sine x. What's the derivative of sine x? Cosine x. Okay, what's next? E raised to u is equal to eu times du over dx. I think this is the formula. So e sine x times du over dx, which is cosine x. Let's see. This is the final answer already. Oh wait, by the way, this is supposed to be like that. Okay. That's it. Number 13. Let's move to 13. I'll screenshot this. I like this question. It's fast. And you know what to do? It's gonna be easy. Okay. Sorry, what are we gonna do here? Bruh. Let's consult the formulas. I think we use this. Let's confirm if I remember it correctly. Okay, just, oh yeah, that is correct. Except that. Okay, this is good. So A is 2. Okay, just copy. ln A times the derivative of U. That's gonna be 1 because the derivative of x plus 1 is 1. So essentially it's this. Can we see? ln 2 times 2 raised to x plus 1. Alright, that is correct. Nice. How about number 14? What is it again? Oh yeah, a raised to x. Whoops. Okay, there is no quotient or product rule here, just a minus sign. So A is 5. Well, you just copy, okay. And then times ln 5 times the derivative of it. What's the derivative of if u is equal to this? Oh no. What is its derivative? No, that's not. 1 over 5 raised to x. Come on, what is this question? Wait, let me... Okay, I think we're using the same formula still. A is 5 raised to x. Times 2. Okay. Oh, sorry. A is just 5. The U is gonna be just... Oh, okay. You can rewrite this one as 5 raised to 2x. I think you can look for the derivative of U one of two ways. So this is 1. Yeah, this is already the derivative. Sorry, that's not the final answer yet. Or you can solve for it this way. So we can rewrite this as 1 over 5 raised to negative 2x. So derivatives, 0 times. Never mind, this does not look appetizing. Okay, so just here. Don't mind that. Okay, so we found U prime. Okay. Something looks off. The answer is said to be this. Oh, wait, we haven't. So we still have a minus x. But the derivative for that is just minus 1. I guess I'll skip number 14. Yeah, that's it for this video. Thanks for watching.